Hello students, how are you? I hope all of you are doing well. Do you remember the things that we have discussed in the last few classes? Yes, we have been discussing about friction. We know that friction is the force that opposes motion. It tries to hold back the object that is moving. Friction causes wear and tear, and there will be some energy wasted in any process because of friction. We have seen that friction also helps us. It is because of friction we are able to walk, hold objects with our hand, machines to work, and so on. So friction is desirable in several situations, whereas it is undesirable in some other cases. We increase friction wherever it is needed, and we have many ways to do this. Also, we have seen various ways of reducing friction wherever it is undesirable. I hope all these things are clear to you. There are some more interesting things to discuss about friction. Are you all ready? Okay, we will start with a simple activity. Look at this. There is a small metal ball in my hand. Here there is some liquid filled in a glass tube. It is an oil. Can you see this? Now I am going to drop this ball in this oil. The ball will be moving down. I want to know how fast it is moving. How do I measure its speed? Do you have any idea? Okay, I will tell you about this. See, I have made two marks on this tube, one here and another here. As the ball crosses this mark, I am going to start a stopwatch, and it will be stopped as the ball crosses the second mark. In this way, I can measure the time taken by the moving ball to travel this distance. Okay, let us start this. Now I drop the ball, and the time is measured to be 2.5 seconds. Now I have emptied this tube. I want to drop the ball and measure the time in this case. I am going to measure the time taken by the ball in the same way as before. Observe carefully. See, now I am dropping the ball. Oh, in this case I could not measure the time because it is moving fast. The ball completed the motion before I could even switch on the stopwatch. So anyway, it is clear that in the second case the ball is moving so fast compared with the first case. So the time taken in the second case is less compared with the first case. Then the question is, why is it happening? So let us try to understand this. So the first question is that why the ball is moving down? We know that it is because of the gravitational force of attraction by the earth. So are these forces different in these two cases? No, it is the same, because we are using identical balls. The mass is the same. So the gravitational force depends upon the mass only. So the gravitational force is the same in these two situations, still the ball moves in a different way. The time taken is different. Why is it happening? Yes, it is the presence of the liquid that makes the difference. What does the liquid do? The liquid opposes the motion of the ball in it. It means that there is a friction. Oh, were you thinking that friction is always between solid objects? No, it is not true. Friction can be there in the case of liquids also. This activity shows the effect of friction on the speed of the moving ball. I hope it is clear to you. I have a question to you. What is there inside the glass tube in the second case? Nothing? No, it is not nothing.
there is air inside. Can this air inside the glass tube affect the motion of this ball? Can there be friction in this case also? Some of you might be confused now, right? Okay, don't worry. Let us discuss it more so that it will be clear to you.
Let us discuss another case. I am sure that there will be no person who looked at the sky, at a clear night sky, and wondered how beautiful it is and how wonderful it is. I am sure at least once all of you might have done this, right?
On a clear night sky, what are the things that you can see? Yes, there will be moon, stars, planets, asteroids, comets, and other celestial bodies. Did you hear about meteors? What are these? Yes, meteors are celestial bodies that comes close enough to Earth and enters Earth's atmosphere. Can you guess what happens once it enters to Earth's atmosphere? Yes, exactly. These meteors fall down after trapped by the gravitational force of Earth. If it falls on the Earth's surface, what will happen? Can you guess? Oh, it will be a disaster. So terrific. Studies tell that around 25 million meteors enter Earth's atmosphere every day. 25 million, it's a large number. But meteorite hitting the surface of Earth doesn't happen that often. The chance is very less. Can you say what happens to these meteors? How are we safe from such a disaster? Yes, it is because of the Earth's atmosphere that we are safe. After entering Earth's atmosphere, it gets heated up and gets burnt. Then it vaporizes and turns into a streak of light in the sky. Most of the time it burns out completely. In such a way, we are all safe. Studies tell that around 25 million meteors enter Earth's atmosphere every day on an average.
Now, can you say why these meteors are getting heated up and burnt? Now, can you say, is there friction in air too? Yes. From this discussion, it is clear that there is friction acting on the moving objects when it is in air also. And it is because of this air friction the meteors are getting heated up and burnt. So, we have seen that friction is there in the case of liquids as well as in the case of gases. What do we call these liquids and gases together? Do you know? Did you hear about the word fluids? What does it mean? Yes, fluid means a substance that can flow. So, the friction present in the case of liquids and gases are commonly called as fluid friction. I hope now it is clear to you. Now, I have a question to you.
So, when we drop a metal ball, after removing the oil, isn't the friction acting on it? Try to find answer for this, okay? Now, let us discuss about the factors that affect the fluid friction. Suppose I use some thick oil, thicker than what we used here. If I drop the same metal ball in such a liquid and measure the time required to travel the same distance, will it be the same? No, it will be more. What do we understand from this? We understand that the fluid friction depends upon the nature of fluid. By nature of the fluid, we mean how thick the fluid is. So, the first factor that affects the fluid friction is the nature of the fluid. Okay? Now, suppose I change the shape of this metal ball and make it more flat. Remember, I am changing its shape only. not the mass. What does it mean? It means that the gravitational pull of the earth remains the same. Then if I drop this flattened object in the oil, what would happen to the time to travel the same distance? Our daily life experience tells us that the time taken will be more in this case compared to the case of the metal ball. So what do you understand from this? Yes, the frictional force would be more in this case. That is, the fluid friction depends upon the shape of the object moving in the fluid also. So another factor that affects the fluid friction is the shape of the object. I hope these things are clear to you. Okay? Now let me ask you one thing. Did you experience that air is pushing you against your motion when you are traveling in a bicycle? Yes, right? If you increase your speed, what do you feel? Is this push by air more? You might have experienced this. What does it mean? The fluid friction increases with the speed of the object moving in it. Okay? Now I have one question to you. Suppose you are moving in a boat with an engine. As you switch on the engine, there will be a force exerted by the engine trying to move the boat. So the boat starts to move. Since the engine is continuously working, there is a force continuously acting on the boat. This force is trying to increase the speed of the boat always. So does the speed of the boat go on increasing? No, it doesn't happen. We experience that the speed increases in the beginning for some time and then it moves with the same speed. Why does this happen? Okay, try to find out the answer for this. Okay. So we have seen that the frictional force on an object in a fluid depends on its speed with respect to the fluid. The frictional force also depends on the shape of the object and the nature of the fluid. These are the factors affecting the fluid friction. Is it clear to you? Now suppose we have to design an aircraft or a watercraft. From this discussion, it is clear that if you want to move in a fluid, then we have to overcome the fluid friction. While trying to overcome this friction, that much amount of energy is wasted, isn't it? But we don't want more energy to be wasted. We cannot get rid of friction completely. So how do we design it in such a way that minimum amount of energy is wasted and we would be able to move more easily? Here the knowledge of the factors affecting the fluid friction helps us. Did you notice the shape of a ship? The shape of a boat? How is it designed? Do you find any similarities between the shape of a ship or boat and that of a fish? Did you notice the shape of an aeroplane? What about the shape of a bird? Is there any similarity? Where do you think scientists or engineers get hints for these special shapes? Okay, try to find out these things. So in this session we have seen that there is friction present on a moving object when it is in liquid or gas, generally when it is in a fluid, and the friction acting on a moving object when it is in a fluid is known as the fluid friction, and the fluid friction depends upon the shape of the object and the nature of the fluid. The fluid friction increases with the increase of the speed of the moving object. The vehicles are designed in such a way that minimum energy is wasted because of fluid friction and more efficiently we can run the vehicle. So I suggest you to read these portions in your science textbook and observe things around you
carefully observe the things around you and try to correlate these things with whatever you are observing. Okay? So, I stop our discussion here. Thank you all for listening. Bye.